Hello everyone, so today in this video we are going to discuss this question element extermination which was asked in Codeforces Global Round 9. In this question we are actually given an array A which is actually a permutation of numbers from 1 to n, and what we are given is, what we have to do actually is we have to find a pair such that AI is less than AI plus 1, and we can either remove AI or remove AI plus 1. In that way we have to apply the operations as many times as we want to, and what we have to see is whether it is possible to us that we can make an array A of length 1 only. So let's understand the question with the help of example. So let's see this example 3124. So in this we can see that initially the array which is given to us is 3124. We found that 1 is less than 2, so we decided either we remove 1 or we remove 2. So here we remove 2, so our array becomes 314. After we had seen that 1 is less than 4, so we decided to remove 1, so we are left with 3 4. After that, okay, we decided to we see that 3 is less than 4, so we decided to remove 4, so we are left with 3. We actually decided to remove 3, or we can remove 4 also. So we can left with either 4 or 3. So we can see that only one element is left in the array. So yes, it is possible for us. So yes, we can say that it is possible that only one element is left after the operations. So we can say, okay, the answer is yes in this case. So this is a very easy question. So let's understand the approach to this question. First, I make a claim to the solution. Then I will prove why this claim is true. So what my claim is? My claim is if A1, that is my first element, is lesser than my last element. Okay, so what my claim? I again repeating my claim. My claim is if my first element, that is A1, is lesser than my last element, that is AN, then answer is yes, else answer is no. This is my claim. So you can code it out easily. If A1 is less than AN, then answer is yes, else answer is no. So let's prove this claim. Okay. So let's say the array which is given to us is A1, A2, A3, A4, A5, A6 and A7. Let's say this is the array which is given to us. So we can see A1 is this and A7 is the largest. A1 is the last element which is given to us. Not the largest, the last element. Okay. So what I say is, let's say I traverse from A1, and okay, what I say is, I say that A1 is less than A7. I'm saying I'm saying that A1 is less than A7. So what I'm saying is, now let's start traversing from A1 and find an element which is greater than A1. So let's say I start traversing from A1. I move to A2, then move to A3, then I move to A4. When I reached A4, I found that my A4 is actually greater than A1. Okay, I found that my A4 is actually greater than A1. If I found that while I'm traversing from A1 to A4, I found that my A4 is greater than A1. If I says that A4 is greater than A1, don't you think it means A2 and A3 are lesser than A1? A2, A3 both are lesser than A1, because I'm traversing from A1 and trying to find an element which is greater than A1. If I'm trying to find an element which is greater than A1, so I found A4. If I found an element which is greater than A1 is A4, so it means A2 and A3 are lesser than A1. So if A2 and A3 are lesser than A1 and A1 is lesser than A4, so let me mark this as equation 1, that A4 is greater than A1 and A2, A3 is lesser than A1, equation 2. So from equation 1 and equation 2, I can clearly say that my A4 is greater than A2 and A3. My A4 is greater than A2 and A3. If I say, okay, my A4 is greater than A2 and A3, then what I can say is my A4 is greater than A3. It means I can remove A3. So now my array becomes A1, A2, A4, 5, A6, A7. I know my A2 is also lesser than A4. It means I can remove A2. Okay. And I also know that my A1 is lesser than A4. If my A1 is lesser than A4, so I can easily remove A4 now. I can easily remove A4. So as I remove A4, so I can see, okay, my array becomes A1, A5, A6, A7. So my array becomes A1, A5, A6, A7. And I know that A1 is less than A7. You can easily think of there can't be any equal to sign as it is a permutation from 1 to n. So now again decided to move from A1 and going to find an element which is greater than A1. So I move. I found that okay, now my A6 is greater than A1. As my A6 is greater than A1, my A6 is greater than A1, and I know that I am finding an element greater than A1, therefore A5 can't be greater than A1, therefore A5 is less than A1. So my A5 is less than A1 and my A6 is greater than A1, so I can easily be able to say that A6 is greater than A5. If my A6 is greater than A5, so I can remove A5. Now I'm left with A1 and A6, A7. I can say my A1 is lesser than A6, so I can remove A6, because either we can remove AI or we can remove AI plus 1. So the element which is left to me are A1 and A7 only. And I know my A1 is less than A7. So what I can do is either I remove A1 or I remove A7. Let's say I decide to remove A7. So element left to me is A1 only. So if my A1 is less than A7, I can definitely say for sure that my answer should be yes. Okay, let's come up with another scenario that A1, A2, A3, A4, A5 is given. Okay, you say okay, A1 is lesser than A5, but okay, let's say try to traverse from A1 and trying to find a number which is just greater than A1. I directly reached A5. I say okay, neither A2 nor A3 nor A4, neither of them are greater than A1. All are smaller than A1, and I directly reached A5 which is greater than A1. It means I can say कि my A2, A3 and A4 are smaller than A1 and my A1 is smaller than A5. I am saying that A1 is smaller than A5. Okay, so my A2, A3, A4 are smaller than A1 and my A1 is smaller than A5. So I can say my A4 is smaller than A5, my A3 is smaller than A5 and my A2 is smaller than A5. So I say my A4 is smaller than A5. So I decided to remove A4. So my array becomes A1, A2, A3, A5. Then I say my A3 is less than A5, so I decided to remove A3. Then my array becomes A1, A2, A5. My A2 is less than A5, so I decided to remove A2. And I know my A1 is less than A5, so either I remove A1 or I remove A5. Let's say I remove A1, so my array remains A5. So in any of the scenario you can take any of the scenarios like this in which the first element is lesser than the last element. You will always find the answer to be yes only. So what we can say is, if first element is lesser than the last element, then the answer would be definitely yes. Else the answer would be no. Else the answer would be no. Okay, my answer would be yes if first element is lesser than the last element. Else my y answer is no. There might be possibility that answer would be yes also. So let's now prove that y else answer would be no. So I am saying else. What I'm saying is if A1 is less than AN, then answer would be yes, and I have shown you why answer would be yes if A1 is less than AN. I'm saying else my answer would be no. Let's now prove this why else answer would be no. We will prove in the same manner which we had done now. What we will do is we will say okay, A1, A2, A3, A4, A5, A6, A7. Now I'm saying A1 is less than A7. Now I'm saying A1 is less than A7. Okay, now this is thing. I decide to traverse from A1 and I trying to find the value which is just greater than A1. I'm moving. I found that okay, A4 is greater than A1. A4 is greater than A1 and A2 and A3 are smaller than A1. What I'm doing is I'm traversing from A1 and trying to find the first number which is just greater than A1. So I found okay, A2 and A3 are smaller than A1 and A4 is greater than A1. So I write it like A2 and A3 both are actually smaller than A1 and A1 is actually smaller than A4. So what I can say is A3 is smaller than A4 by this relation. So I will remove A3. A2 is smaller than A4, so by the relation I remove A2. A1 is smaller than A4, so let's say by the relation I decided to remove A4. So the elements which is remain to us are A1, A5, A6, A7. A1, A5, A6, A7. So now I further decided to start from A1 and find the element which is just greater than A1. So I traversed. I found that okay, I found no element. Which is greater than A1. Let's say in this case I found no element which is greater than A1. If I found no element which is greater than A1, then one thing I'm definitely sure is all the elements to the right side of A1 are smaller than A1. If all the elements to the right side of A1 are smaller than A1, then it would be impossible for me to remove A1, because we can remove either AI or AI plus 1 if and only if AI is less than AI plus 1. But here AI, that is A1, is not smaller than any other element, so it is impossible for us to remove A1. Okay. So A1 is fixed. A1 won't be removed. So let's pick up a good scenario over this sequence. Let's I say in the best case, let's say A5 is less than A6 and A6 is less than A7. In the best case, I say this. So you will say, okay, this is the best case. So if A6 is less than A7, what I will do is I will remove A7. You will say, okay, A5 is less than A6. So let's say I decided to remove A6. So we are left with A1, A5, in which I know A1 is greater than A5. So I can't be able to remove A1, or I can't be able to remove A1, and I can't be able to remove A5. So I can say at the end two elements are left to me. So I can claim that the answer would be no in this case. So this proves my claim. So the code is very easy. If you like this video, do share and subscribe.